Hi everyone, I'm Nikhil, and in this video we'll try to solve the first question in the top interview 150. We'll start off with the first easy questions in every section, then we'll focus on the mediums and then on the hard. But for this particular video, we are solving the very first question, which is the merge sorted array. Now the primary purpose of me making this video is to reach out to more number of people in order to gain some feedback or some criticism. I want to gain feedback on my explanation process and on my coding process. So this video is not for advanced level programmers, it's not a tutorial, but if you can gain something out of it, it would be highly grateful for me. So I'll try to explain this problem first visually, and then I'll try to code it in JavaScript. So if I make sense to you, please let me know, and if I don't make sense, then please let me know how I can improve myself. It could be on the coding process, it could be on the explanation process, or anything related to the entire process. So we'll begin our session with the diagrammatic explanation of this question. So let's begin. So before proceeding to the coding implementation, we can first try to understand the question in a visual manner. For that purpose, I have drawn this simple diagram in draw.io, and I am taking this particular example 1 over here for us to understand. So simply, as we can see, I have taken nums1 array, which is equal to 1, 2, 3, 0, 0, and I have taken nums2 array, which is 2, 5, and 6, as written over here. And then I have taken m and n, which is equal to 3. So m is equal to 3, n is equal to 3. So the idea here is to compare elements from both these arrays, and whichever is the greatest, we can assign it to the end. Now how we'll do that? So we'll take a third variable k. The primary purpose of this variable is to access the last available position in our array. So as per the question, we have to make changes in nums1 array. We do not have to create any new array, but change the elements in nums1 only. So I've written all of these over here, and I mentioned k over here just to denote the updated array. So I've taken this variable k over here. Now the main purpose is to access the last element, so that we can put the comparison, and then we can put the relevant element to the last. To the right side, we can see that I mentioned a pseudocode over here that will compare the I and j, I of nums1, j of nums2. Do the comparison, whichever is bigger, we'll place it at k, or else this thing. Okay, so I've taken a variable I, which points to this element 3. Why not 0? Because it's mentioned in the question that the last n elements are set to 0 and should be ignored. That's why our I is pointing here, our j is pointing here, and as per the algorithm, we can compare both of them. Whichever is the greatest, we can take this and put it to the end. Okay, again we can do the comparison between the last two elements of both these arrays, which is 3 and 5. Whichever is the greatest, we can just put it here. Okay, alright. Similarly, we can do the comparison between 2 and 3, and we can put it here. So you get the idea. So what do we have to do is, we can take 2 pointers. Both of them will be pointing to the last location of nums1 and nums2. Whichever element is the greatest, we'll take that and put it at the last of nums1, right? So this is the approach that we are going to follow, and we'll try to implement this. Let's see how it goes. Okay, So now let's begin with the coding implementation of our program. So we'll follow this algorithm over here and we'll follow the approach that I discussed in the previous section. So first of all, let's declare a variable which is I, which will point to the last element of nums1. That's it. Now we'll take one more variable which will point to the last element of nums2, right? And we have to take one variable which will give us the access of last available position in nums1 array. So we have taken three variables, I, j and k over here. Next we can implement a while loop which will check the values of I and j. So while I should be equal to greater than 0 and j should be greater than equal to 0. So when both of these conditions are true, we must implement something. And inside this while loop, we'll try to fit this. So if nums1 of I is greater than nums2 of j, so in this case what we'll do is the last position, that is nums1 of k, should be filled with nums1 of I. If this is not true, then what we can do is nums1 of k should be filled with nums2 of j. In both of these conditions, we have to move one position back in our kth k array. So what we can do is we can minus k over here. But if we take one position from I or one element from I or one element from j, we'll have to shift or decrement the overall length of particular array. So we'll first, in this, we'll decrement the length of I. Here we'll decrement the length of j. So this is our implementation based on the discussion that we did before and based on this particular algorithm. So let's try to run it. Alright, so case 1 is okay, case 2 is okay, but case 3 is not okay because there are no elements in nums1, but there are some elements in nums2 which are not processed by this particular while loop. So we have to take care of edge cases also. Now it might be possible that our while loop is executed, but still there are some elements in j. So we'll have to take care of this. So we'll have to implement one more j loop. So while j is greater than equal to 0. So here what we can do is in nums1 of k, we can simply put whatever remaining elements that we have from j. We can decrement k over here and decrement j over here. So if we try to run it now, alright, all the cases are now passed. So I'll explain this one more time. So the thing is, we've taken a variable I which points to m-1, a variable j which points to n-1, and a variable k which allows us to get the access of the last available location in nums1. In the first while loop, we are simply comparing I from nums1, j from nums2, and then we are placing the relevant element in nums1k. Here we are decrementing I. We're repeating the same procedure over here for j, and in both the cases, if or else, we are just doing k minus minus. After this loop executes, there might be some elements which are not processed, and in order to deal with those edge cases, we have created another while loop where the condition is that some elements in j are still left. So if j is equal to so greater than or equal to 0. So we can just put nums1k is equal to nums2j, and we can decrement both of these values until all the values are processed. So we'll try to submit this now. Alright, so this is our final implementation. Alright, so this was our implementation of the merge sorted array. So we discussed the problem in a diagrammatic manner, and then we implemented it using JavaScript. As you can see, the solution is not perfect because it beats only 32.30% of users with JavaScript, but the runtime is, I think, optimal. It's 59 milliseconds. I know there might be people who can attempt the entire question in 1 line or 2 lines, but I'm trying to improve myself, and so if you have any suggestion on how I can go one level up, and if this question can be attempted in some other way, please let me know. I'll be happy to implement it, and I'll try to take as much as inputs from you guys, and I'll try to improve myself and be more professional in my coding. Thank you.